So now we come to the point, why is it not taken off? Why hasn't it taken off? Is because of its mechanical and microstructural properties. Let's say you want to make a stand out of it. So you do not want that stand to buckle or to bend or to crack. Now in a machine, there will be so many vibrations and then other components sitting on it, or it would be subjected to all sorts of friction forces. Now to get a certain mechanical property, you need to go and look into what the microstructure is. What the microstructure is dependent on how liquid solidified, and we have not understood that well the microstructure or the solidification science during the additive manufacturing process, and that is what
research is pending, big knowledge gap.
Yeah, I would like to give you an example. You would have seen there'll be a swordsmith who would be heating the sword to a very high temperature, red hot, and then would hammer it, and then after he has sharpened it, then he would immediately put it in water. So that is what is called as quenching. Now why not leave that sword just as it is? That would change its properties. So if you do not cool it quickly, you will not get that strength that you want in this sword. So it would be little soft. So what it means is that how you come from that melting temperature or from a very high temperature to its room temperature, and now there is so many things that happen there.
Movement of atoms, arrangement,
how the atoms get arranged, what sort of phases form. Microstructurally, whatever happens at atomic scale and microstructural scale.
So you mean, so we don't get desired mechanical properties in 3D metal printing yet because there's a huge knowledge gap.
Knowledge gap is pending for lots of material. The classic difference between additive manufacturing and the casting based processes is that in casting process you put it in water or oil, you quench it, so it's a predictable cooling pattern, and people have worked for decades and centuries to come up with certain kind of mold and the cooling mechanism for a particular material to get a particular mechanical property. Now in additive manufacturing process, because you're doing layer by layer deposition, so it's like you deposited some material in liquid form, it turned into some small region, turned into liquid, solidified, but you are moving the laser or the electron beam, so locally the parts are getting melted and then solidified
layer by layer by layer.
So it's a very complicated heating and cooling cycle,
added complexity,
which is where the research is going on to understand the solidification process. Our lab precisely works on the understanding the solidification mechanism.